Okay, YouTube, in this video we're going to be exploring how we could use this new definition of the trig functions as well as knowing where our trig functions are positive and negative in order to find, say, some unknown trig function values. And so what I'm going to start with is this. We're going to assume in this problem here that theta is some angle that's between 0 and 360 degrees, and it's written or at least sketched in standard position. So when we look at what we know here, we say given the tangent of an angle here, theta is negative 1/3, and that our cosine value of theta is just simply negative, what we want to do is go find the values of sine and secant. And so what I'm going to do is I'm going to start by admitting that our tangent of theta here, that's found by taking our y value divided by our x value here. So what I'm going to do is I'm going to start by kind of sketching our situation here and looking at the fact that our tangent value is negative. I would know that our tangent value could not be in the third quadrant, and nor could it be in the first quadrant because our tangent values would be positive there. Now, by telling us that the cosine value is negative, we also know that we cannot be in the fourth quadrant because that would be a positive cosine value. So the first thing we're going to do is essentially this. We're going to say that our angle here, and it's not very well drawn, I apologize, must be some angle that lands in the second quadrant. We're going to label this with a theta. So now the nice thing about this is we know some point on the terminal side xy. And looking at this here, we would say that given that our tangent is y over x, that is, we say that we have a negative 1/3 here. Essentially, this can only be negative if the y is positive and the x is negative, or the y is negative and the x is positive if these have different signs. So when you look at this situation here and we say, okay, well, I know that my y value is 1 because that's my top number here, and my x value is 3, that's my bottom number. When it comes down to which one of these is the negative one, you just need to verify it visually that our x value is this negative dimension here. So we know that this is negative 3 and that this is 1. The only value that we don't currently know is this value of r. And so because we know that r is the distance back to the origin and is equal to x squared plus y squared when we know our x and y values here, which we do, then we could say that our r value in this case is going to be negative 3 squared plus 1 squared, the square root of that. And so what we end up with is the square root of 9 plus 1, or that r is equal to the square root of 10. So I'm going to go ahead and list this up here on my picture. I'm going to say that this is equal to the square root of 10. I'll put this in a different color here. So with that listed now, we could say I want to go find the sine of this angle. Well, the sine of this angle, recall, is just our y value over our r value. So our y value we've verified is 1 just from the picture here, and our r value is a positive square root of 10. And so we should rationalize this and write this as the square root of 10 over 10. Now looking for the secant value. The thing with the secant is, before I can tell you the secant, what I'm going to want to probably know is my cosine value, which is x over r. So our cosine value, or x value, is negative 3, and our r value is the square root of 10. And so I should rationalize this, but for right now, since I know that I want to go find the secant, what I'm going to do is I'm going to go ahead and I'm just going to go ahead and turn this over and make this the square root of 10 over 3, and I'll just put the negative out in front here. But this would be our secant value. So knowing the sine values, SIGN, sine values of your trig functions, and also at least one of the values of one of your trig functions, we should piece together, be able to piece together what the other trig value functions are if we want to find them. Cheers.